Hey guys, so we're going to look at our first set of notes for the college algebra class. And like I said in our meeting, the first part of this class is going to really be a review of Algebra 2. You're going to see a lot of Algebra 2 actually through the first portion of this course. And this is going to lead up to going into logarithms and exponential equations, which we'll see at the end of the class. So today, I know you may get bored and say, really, we're talking about the distance and midpoint formula. Some of you may have forgotten that, so we do want to discuss it. We want to make sure that everybody's on the same page and understands what we're talking about when we're looking at future content in the class. The first thing we want to make sure that we break down is what we call the rectangular coordinate plane, which is also the Cartesian plane. And the Cartesian plane is just the traditional XY axis. That's what you guys are used to seeing. Later on we will look at the complex plane, but the Cartesian plane or the coordinate plane is just the simple XY axis that you can see over here on the left of the screen. We have the coordinate plane there. When we have a point in the ordered or on the coordinate plane, we call that point an ordered pair because it has an X value and a Y value. It gives it kind of an address in the coordinate plane. And you can see that here in the middle of the screen. And then on the right-hand side, the coordinate plane is divided up into 4 quadrants. Quadrant 1 is the top right, and X and Y are both positive. Quadrant 2 is the top left, and the X is negative, Y is positive. Quadrant 3 is the bottom left, where X and Y are both negative. And then Quadrant 4 is the bottom right, where X is positive and Y is negative. The distance formula is what we're going to look at here right now. We're going to kind of break that down. And the first thing that we're looking at with example 1 is find the distance between the points 1, 3, and 5, 6. So on the plane, we're going to mark these points. And let's see. So we have 1, 3. And then our second point is 5, 6. So we're going to go over 1, 2, 3, 4, 5. And then up 6. We are looking for the distance between these 2 points, and I'm going to go ahead and label these 1, 3, 5, 6. Now we're not going to jump straight to the distance formula. We're going to use what we know about geometry to come up with that value. So you see that I've drawn a right triangle here, and if you remember anything from geometry, one of the first things that probably pops into your mind when you see a right triangle is the Pythagorean theorem. And the Pythagorean theorem is simply a squared plus b squared is equal to c squared, and c squared is your c is your hypotenuse, a and b are going to be the legs. So we need to first compute the length of both legs. So this first leg, it has an x value of 1 up to an x value of 5, so we know that that's going to be 4 units long. And then the height has a y value of 3 up to a y value of 6, so we know that the height is 3. If you remember anything else from geometry, you can already see that this is a special right triangle. It's what we call a 3, 4, 5 right triangle, so we already know the hypotenuse is 5 units long. If you don't see that, that's fine. We're going to go ahead and substitute these numbers in and come up with the values. Sorry, the phone was ringing. You guys heard that though. So I'm going to substitute in these values for a and b. So I have 3 squared, and the phone is ringing again. So give me just a moment. The joys of virtual learning. Hopefully the phone won't ring anymore. But we just substitute in the values for a and b. So we have leg squared plus leg squared equals hypotenuse squared. We know that 3 squared is 9. 4 squared is 16. And then when we simplify this, we get 25 is equal to c squared. And then when we take the square root of both sides, we end up with 5 is equal to c. So we found that the distance between the points 1, 3, and 5, 6 is 5 units. And we're going to use this information that we just computed with the Pythagorean theorem to derive the distance formula. All right, I apologize for the starts and stops here in the video. I've had a couple things going on here at school. So as I mentioned when we were doing example 1, we were going to derive the distance formula from the Pythagorean theorem. And you can see right here on the Pythagorean theorem, when we solve that for c, this is essentially saying that we have c is equal to the square root of the sum of the squares of the lengths of each leg. And that's what we find down here with the distance formula. It's the distance between 2 points is equal to the square root of the sum of the distances between the values, which is, so you see this x sub 2 and x sub 1. That is going to be 5 minus 1 in the case up here, which is equal to 4. And then in the case of the y values, it's y sub 2, which is going to be 6, minus y sub 1, in this case, which is 1, or 3, sorry. So 6 minus 3 is 3, and that's exactly what we did in our first example. So the distance formula is going to be the difference between the x values, and then you square that quantity, plus the difference in the y values, you square that quantity, add them together, take the square root, and you can find the distance between 2 points. Here's a proof of the distance formula. If you're interested in that, you don't have to know this proof inside out, but it would be something useful to look over just so you can understand how it is derived, rather than just the kind of glossed over example that I just gave you. So here in example 2, we are actually going to apply the distance formula, and I'm just going to first write out what the distance formula is one more time. And so there's our distance formula. And a lot of times it may be helpful, just as you build up practice with this, to label your points. So the first order pair, I always label x sub 1, y sub 1. The second order pair is x sub 2 and y sub 2. So now it's just a matter of substitution. So when we go in and make our substitutions, our x sub 2 value is 3. Our x sub 1 value is negative 3. And then when we do it for the y values, we have 2 minus 5. And we simplify. So we have 3 minus negative 3, which is the same as 3 plus 3. So we have 6 squared plus negative 3 squared. And then when we square everything, 6 squared is 36. Negative 3 squared is 9. And this is going to be equal to the square root of 45. Now, the square root of 45 is correct. However, it is not an exact answer. We can simplify that a little bit further. We know that the square root of, or we know that 45 is the same as 9 times 5. So we can rewrite this as the square root of 9 times 5. And one of the nice properties about square roots is that we can break apart multiplication. That does not apply to addition and subtraction, so do not try to separate addition and subtraction underneath a radical. If you have multiplication or division under a radical, you can separate those like we did right here. So we know the square root of 9 is 3, and the square root of 5 is what we would call an irrational number, so it doesn't simplify any further. So an exact answer for this problem would be that the distance is 3 radical 5. For right now, if you left it as the square root of 45, I'm not going to take off, but I want you guys to start getting in the practice of simplifying radicals as much as you possibly can. Example 3, we're looking again at the distance formula a little bit more. And so we have 3 points, A, B, and C. We want to plot each point to form a triangle that's called ABC. Find the length of each side, verify that it's a right triangle, and then find the area of the triangle. So let's go ahead and start off first by plotting our points. So the point A is at negative 2, 1. And I'm going to use each one of these little tiny hash marks as one unit because I didn't give myself enough room to the left. So my first one is going to be 2 units to the left and 1 unit up. So there's point A at negative 2, 1. Point B is going to be at 2, 3, so we're going to go over 1, 2, and then up 3. And then point C is at 3, 1, which is going to place it right here. I really should have given us a larger graph to work with. So I can connect these dots, and I can see obviously it does form a triangle. The question is asking us to first find the length between all 3 points, or all 3 sides of the triangle, and then we want to verify whether or not it's a right triangle. So we've done part A. We want to move on to part B. We want to find the length. So the first one, we're doing part B here. Let's find the distance from A to B. And so the distance from A to B, we're going to use the distance formula. It's x sub 2 minus x sub 1. So we have -2 minus 2, quantity squared, plus, then it's going to be y sub 2, which is 1 minus 3, quantity squared. And we're going to end up with -2 minus 2 is -4. And 1 minus 3 is -2. And when we simplify that, when we square -4, we get +16. When we square -2, we get +4. And we have the square root of 20. That's the distance from A to B. Now let's look at the distance from B to C. For B to C, it's going to be x sub 2, which is going to be 2, minus 3, quantity squared, plus 3 minus 1, quantity squared. And so we get -1 quantity squared is +1, 2 squared is 2, or 4 rather. And so we get the distance between these 2 points is the square root of 5. And then the last one we want to look at is the distance from A to C. And in this case we'll have -2 minus 3 quantity squared plus 1 minus 1 quantity squared. And when we simplify this, -2 minus 3 is going to be -5. 1 minus 1 is 0, so we're not even going to write that down. And what we end up with is the square root of 25, which is equal to 5. So we found all 3 of our distances. From A to B, it's radical 20. From B to C, it's radical 5. And then from A to C, it is 5 units. For part C of this problem, it asks us to find whether or not, or to verify that this is a right triangle. So the way that we verify something is a right triangle is through the Pythagorean theorem. So it's a squared plus b squared is equal to c squared. And the only way to do this is first we have to determine which one of these lengths represent, or which 2 of these lengths represent legs of a triangle, and which one could possibly be the hypotenuse. You're going to see some of the suggested problems later on this set of notes where it doesn't always work out that it forms a right triangle. But if you're testing whether or not a triangle is in fact a right triangle, the longest side is the one that you will use to test as your hypotenuse, because on any right triangle the hypotenuse will always be the longest side. So in the case of this example, the longest side is the side that's 5 units long. So that means the other 2 sides have to be the legs of the triangle. So if we substitute this in, we have square root of 20 quantity squared plus square root of 5 quantity squared equals 5 squared. When you square a square root, basically the square root just goes away. So now we have 20 plus 5, and I should put a question mark here because we're testing whether or not this is true. And then 5 squared is 25. 20 plus 5 is 25. 25 does in fact equal 25. So you can say that yes, this is a right triangle. So we were able to verify that just by using the Pythagorean theorem. And then part D says find the area of the triangle. Remember, the area of a triangle is 1/2 base times height. So we can look at if we rotated this triangle around, and maybe looked at it this way, we know that this base is square root of 5 units, and we know that this height is square root of 20 units. So when we compute the area, so this is part D, area of a triangle is 1/2 base times height. So in the case of this particular triangle, we do have that it is square root of 5, height is square root of 20. We can do the multiplication of these two items together, which is going to be the same as square root of 5 times 20. Remember, previously we separated it. We can also combine multiplication. So that's the same as the square root of 100, which is 10, and 1/2 of 10 is 5 units. So the area is 5 square units, whatever these units may be. Another thing that you could do as well, if you wanted to, since we do have the diagram, just to verify this solution, is we can actually count the distance from point A to point C, and we see that that is going to be -2 to 3. That's 5 units. And then the height of the triangle can be found from this point. We're looking at a vertical height, which is going to be 2 units tall. And we can apply the same formula again. It's 1/2 base times height. And we get 1/2 times 10. And that's still 5 square units. So there's multiple ways you can go about coming up with these solutions. What I did over here in the purple on the right for part D probably is it's the same approach as what we did for what I did over here in the black, but it's just a verification of our solution. And so this kind of talks about how we derive the midpoint formula. The midpoint formula is the point that is exactly between two other points on a coordinate plane, and the midpoint formula is going to be one of those that should be fairly easy to remember. It's simply a matter of taking the two x values that you're given and adding those together and dividing by 2. Take your two y values, add them together, divide by 2, and that's going to generate the ordered pair that gives you the midpoint. And that may be more clear when we look at example 4. So we're finding the midpoint of the line segment from P1 to P2. And so the midpoint is going to be equal to the sum of the x values. So we have -5 plus 3 divided by 2. And then the sum of the y values, 5 plus 1 divided by 2. And I put it in the ordered pair notation already. So -5 plus 3 is -2. And 5 plus 1 is 6. And then when we simplify these two fractions, we get -1, 3. So -1, 3 is the midpoint. That's exactly halfway between P1 and P2. So there's your suggested problems. If you recall what I talked about during our introduction to the class today, these are not required. I do suggest that you do them. That's why they're called suggested problems. Your class grade is based strictly off quizzes and exams. That is a university policy. That is not my policy. So when I give you all quizzes, your quizzes will come from the suggested problems. Those quizzes can come at any time. I will give you at least a day or two notice to let you know, hey, you're going to have a quiz today. But make sure you are at least looking at these problems. If you have difficulty with any of these problems, let me know, and we'll go over those together when we meet in our virtual meetings. But just take a look at these. Make sure you understand how to do them. If you're comfortable with them, great. If not, ask me questions, and let's get you through these problems so that you can be successful in class. So I hope everybody is having a wonderful day. I hope that today wasn't too stressful, and I will be talking to you all very soon.